you on Curiosity Stream.
I'm James Burke. I'm going to take you on a journey through time.
James Burke's visionary series returns, reimagined for our time.
Now, this is all uncharted territory.
The Washington Post hails Burke as one of the most intriguing minds in the Western world. The New York Times raves he careens from one great moment in history to another.
Where do we want to go from here?
Experience all new connections.
So what's the next connection?
With monthly, annual, and bundled plans, find the one that works for you at CuriosityStream.com.
Well, shopping for a car?
Yep, Carvana made financing a car as smooth as can be.
Oh, yeah?
I got pre-qualified instantly and had real terms personalized just for me.
Doesn't get much smoother than that.
Well, I got to browse thousands of car options on Carvana, all within my budget.
Doesn't get much smoother than that.
It does. I actually wanted a car that seemed out of my range, but I was able to add a cosigner and found my dream car.
It doesn't get much...
Oh, it gets smoother. It's getting delivered tomorrow.
Visit Carvana.com or download the app to get pre-qualified today.
This is SpaceTime, Series 23, Episode 90, for broadcast on the 2nd of September 2020. Coming up on SpaceTime, Southern launch to carry out its first test flight this month. A new study shows Europa's surface ice sheets aren't connected to its core. And CHEOPs' search for other Earth-like planets. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Southern Launch says it will carry out its first suborbital test flight in the South Australian outback on September the 15th. The DEWC SP-1 mission from the Coonabit Test Range, 40 kilometres northwest of Ceduna, will utilise a DART 2-stage rocket to fly an experimental electronic warfare test payload. The DART's a small 2.4-metre tall sounding rocket developed in the Netherlands by T-Minus Engineering and designed to achieve an apogee of 120 kilometres. DART's based around a 34-kilogram booster stage, which will burn for just 6 seconds. But that'll be enough to accelerate the launch vehicle to Mach 5 before releasing its needle-like upper payload stage. The mission payload for the flight will be a prototype DEWC Miniaturized Orbital Electronic Warfare Sensor System, or MOES, which is being developed under the Project Jericho program. For the mission to be successful, the payload needs to reach an altitude of at least 100 kilometres before deployment in order to pass through the main beam of the target radars. It'll then return back to Earth, eventually parachuting to the ground some 35 kilometres downrange. The payload will conduct its sensing mission as it descends, paving the way for future developments towards a sovereign Australian space-based electronic warfare capability. The overall test flight's expected to last about 30 minutes, demonstrating that small and inexpensive sensors can be rapidly deployed at high speed. DWC provides specialist electronic warfare capabilities for the Australian Defence Force and its allies. The Coonabit Test Range, which extends for some 145 kilometres from the indigenous community of Coonabit, is the largest privately operated rocket test range on the planet. Unlike most launches, which are done over water, test ranges like Coonabit and the Air Force-operated Woomera rocket range, which is a further 330 kilometres to the northeast, allow rockets and their payloads to fall into uninhabited land, where they can be recovered for examination. This is SpaceTime. Still to come, a new study shows Europa's surface ice sheets aren't connected to its core, and CHEOPs' search for other planets like Earth. All that and more still to come on SpaceTime. A new look at high-resolution observations of the frozen surface of the Jovian ice moon Europa show that it's rotated by some 70 degrees over the past few million years. Movement of the icy shell means Europa's poles aren't where they used to be. A report in the journal Geophysical Research Letters claims this could only happen if the icy shell is uncoupled or floating free, separated from the rocky core of the moon by a global subsurface liquid ocean. As well as supporting earlier evidence for the existence of a subsurface ocean, the new findings also mean that the geological history of Europa's surface will need to be re-examined. The The study's lead author, Paul Schenk from the Lunar and Planetary Institute, says large global-scale circular patterns on Europa's frozen surface most likely formed during a large reorientation of its icy outer shell with respect to its spin axis, a process known as true polar wander. The evidence shows that the fractures associated with this true polar wander are younger than the rest of the landscape on the Moon because they're cutting across all the terrains. The authors reached their conclusions using a combination of global maps from NASA's Galileo and Voyager spacecraft with improved computer-generated resolution and detailed topographic data. It's all part of the preparations for the upcoming Europa Clipper mission to the Jovian ice world. The authors correlated large fractures on the surface with previously identified concentric circular depressions. NASA's Galileo spacecraft orbited Jupiter between 1995 and 2003, returning hundreds of images of Europa's surface. Reconstruction of the global map of Europa at 200-metre resolution in colour in preparation for the return to Europa revealed that these mysterious fracture systems were part of the circular true polar wander patterns identified previously. Topographic mapping of the highest resolution images of the fractures at 40 metres per pixel show the fractures to be more than 200 metres deep. These fractures cut through all known terrains and thus show that the deformation is related to the global reorientation or true polar wander event that was one of the last events to occur on Europa. The features also imply that the floating ice shell which surrounds Europa may have thickened over time. This is SpaceTime. Still to come, the European Space Agency's CHEOPs mission completes its in-orbit test phase in preparation for its search for other Earth-like planets. And later in the science report, worsening climate change causing Arctic sea ice cover to reach new record low levels. All that and more still to come on SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
European Space Agency's Characterising ExoPlanets satellite, or CHEOPs, has completed its in-orbit test phase. The operation was made all the more novel because mission managers were forced to work from home because of the ongoing COVID-19 coronavirus pandemic. Despite the lockdown, scientists, engineers and technicians were able to put CHEOPs through its extensive testing and calibration phase, finding the spacecraft is working nominally. CHEOPs was launched back on December the 18th last year aboard a Soyuz rocket from the European Space Agency's Kourou spaceport in French Guiana. Since then, it's been circling the Earth in a polar orbit at an altitude of 700 kilometres. The 273-kilogram spacecraft has now commenced its initial 3.5-year science mission. CHEOPs is designed to characterise the transits of exoplanets, measuring changes in the brightness of a star as a planet passes in front of or transits that star. This measured value allows the size of the planet to be derived and for its density to be determined on the basis of other data about its mass, derived from its gravitational impact as it orbits its host star, causing the star to exhibit a telltale spectroscopic Doppler shift or wobble. This combined data provides important information on exoplanets, such as their composition, that is, whether they're predominantly rocky or composed of gases, or if they have deep oceans. And this in turn is an important step in determining whether a planet would have the sort of conditions which would be habitable for life. Scientists have so far discovered more than 4,000 exoplanets. ESA project scientist Kate Isaac explains what scientists hope to find in this report by ESA TV.
Hi, my name's Kate Isaac. I'm a physicist and I work at ESTEC, which is in the Netherlands, and it's the technical centre of the European Space Agency. I work on a science mission called CHEOPs. CHEOPs stands for Characterising Exoplanet Satellite, and what we're going to do is to measure very precisely the sizes of exoplanets that have been found by other people. The Earth, Mars, Jupiter and Mercury are all planets that go around or orbit the Sun, which is our star. These are 4 of the 8 planets in our solar system. An exoplanet is a planet that is outside our solar system. It is typically orbiting a star, although it doesn't have to be. As of July 2020, we know of more than 4,000 exoplanets that have been discovered in searches that have taken place both from the ground and from space, using space missions that are operating above the Earth. These searches have found many unexpected types of exoplanets and have produced many surprises. Many planets that are very different from those that we are familiar with. Planets much smaller than the Earth, larger than Jupiter, the most massive planet in our solar system, also the largest, as well as planets that are much hotter and much colder than anything we have in our solar system. Planets with temperatures higher than molten lava inside a volcano and higher than the melting point of iron. The first exoplanet discovered orbiting a star similar to our own Sun was discovered in 1995 from the ground. 51 Peg B has a mass of about half that of Jupiter, but that's where the similarity stops. It's orbiting a star called 51 Pegasi, which is reasonably bright as stars go, but still not quite bright enough to be seen by our own eyes when we look up at the sky. The planet has an orbital period of just over 4 days. This compares with an orbital period of the Earth, which is 365 days or 1 Earth year. So 1 year on 51 Peg B is much, much shorter than that on the Earth. The planet is much closer to the star, which means that the planet is very hot. It is in fact more than 4 times hotter than the Earth is. Although to date we have found more than 4,000 exoplanets, we still haven't found one that is exactly like our own Earth. We are continuing to look, of course, but in the meantime we're trying hard to understand more about what we've already found, about the exoplanets that we've discovered to date. We ask ourselves, what are they made of? Are they rocky? Are they icy? Are they big balls of gas? Also, what we would like to know, and what we're interested in finding out, is how they were born and how they age, as well as whether they have atmospheres like our own Earth. All the time we're thinking in the back of our minds whether there is an exoplanet out there where in the future we could possibly look for and find signs of life. Travelling to an exoplanet is not possible today, as even the nearest ones are much too far away. It would take light more than 4 years to travel from the Earth to the nearest exoplanet we know of, which is in the Proxima Centauri star system. As of today, we can only travel at a very small fraction of the speed of light, and it would take us tens of thousands of years to reach the exoplanet. This is much longer than a human lifetime, much longer than the lifetimes of many human generations, in fact.
Wells Fargo presents one of the surest ways to grow your money, a Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns more than 100 animal species, including old world primates, as well as deer, whales, dolphins, cats and dogs, are potentially susceptible to COVID-19. The COVID-19 coronavirus, which has spread globally from Wuhan, China, has infected over 25 million people, killing more than 900,000. Researchers looked at the DNA sequence coding for the ACE2 protein that the virus uses to enter cells to see its potential as a receptor for the virus in a range of different animals. A report in the Journal of Proceedings of the National Academy of Sciences found that old world primates such as baboons, macaques and great apes will have ACE2 proteins with a very high likelihood of binding to the virus. The authors warned that about 40% of the species potentially susceptible to COVID-19 are classified as threatened by the International Union for the Conservation of Nature, and these may be especially vulnerable to human-to-animal transmission. Meanwhile, doctors are reporting an illness linked to COVID-19, which is leaving children with multiple organ dysfunction and body-wide inflammation. A report in the journal Nature Medicine claims scientists have studied 25 children with the disease, multi-system inflammatory syndrome, who were infected or were likely infected with the coronavirus. They found the children had a similar immune response to an adult with COVID-19, and the illness appears to be distinct from Kawasaki disease, another inflammatory syndrome which has been linked to the virus. Scientists say more research is needed to understand the cause of the disease and its relationship with SARS-CoV-2 infection. A new study shows that worsening climate change has caused Arctic sea ice cover to reach a new record low for the month of July. The new satellite data from NASA shows the sea ice extent averaged some 7.28 million square kilometres in the month of July. That's 2.19 million square kilometres below the 1981 to 2010 average for the same month, and some 310,000 square kilometres below the previous record low set last year. Unusually warm air temperatures in May and June over Siberia set the stage for rapid melting in the East Siberian and Laptev seas, while ocean currents helped flush ice out of the Russian Arctic coast, thereby opening the Northern Sea Passage. A new study has found that your smartphone can detect how much you've had to drink simply by detecting changes in the way you walk. A report in the Journal of Studies on Alcohol and Drugs claims having real-time information about alcohol intoxication could be important for helping people reduce alcohol consumption or alerting a sponsor for someone in treatment. The study involved 22 adults aged 21 to 43. Each received a mixed drink with enough vodka to produce a breath alcohol concentration of 0.2. They then had their breath alcohol concentration analysed at regular intervals as they walked a straight line, turned around and walked back again, while carrying a cell phone. The cell phone measured acceleration as well as side-to-side vertical and forward and backward motions as they walked. And by looking at the patterns, scientists were able to determine the participants' level of inebriation for about 90% of the time, simply based on changes in how they walked. Personally, I'd like to know how to become a subject in one of these trials.
And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from SpaceTimeWithStuartGary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through SpaceTimeWithStuartGary.com for all the details. If you want more space time, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.